Greetings everyone. Today, me and my team will be presenting about boiler temperature monitoring system for the subject of instrumentation. This is our team, Yuvan Raj, Sarvesh, myself, Devashan, Vignesh, and also Ganesamurthy. So now, let's look at the type of transducers. First off is thermocouples, second, thermistors, third is resistant temperature detectors, also known as RTDs. The fourth is infrared temperature sensors, IR, and the fifth is bimetallic thermometers. So now let's look at bimetallic thermometers. First off, there's four types of them. The first one is spiral bimetallic thermometer. The second is the helical strip bimetallic thermometer. This third is flat strip bimetallic thermometers. And the fourth is disc bimetallic thermometers. So, how does this bimetallic thermometers work? First off, it works depends on the thermal expansion. Metal expands and contracts at varying rates when heated. The second working principle is the thermometer is manufactured by joining two thin strips of metal. Most commonly used are copper, steel, or brass. The metal's thermal expansion coefficients determine their selection. Now let's look at thermistors. There's two types of thermistors. The first one is NTC, also known as negative temperature coefficient. The second one is positive temperature coefficient, also known as PTC. The materials used to do these thermistors are semiconductor materials and also polycrystalline ceramic materials. Next up, let's look at the resistant temperature detectors transducer, also known as RTDs. There's three types of RTDs. The first one is wire wound RTDs. The second one is thin filmed RTDs. The third one is coiled RTDs. These RTDs are basically done with platinum, but nickel and copper are sometimes used. Next up, it's the infrared temperature sensor. So there's three types of them. First one is IR spot thermometers. The second one is infrared cameras, also known as thermal imagers. The third one is fiber optic IR sensors. Now let's not get deep into it because there's another important part of transducer which we're going to use for the project. Now this is the transducer we're using for the project, the thermocouple type K. So the materials used in this thermocouple is for the positive wire we are using chromel, an alloy of approximately 90% nickel and 10% chromium. And also for the negative wire we are using aluminum, which is 95% nickel, 2% manganese, 2% aluminum, and 1% silicon. So the construction of this is the chromel and aluminum wires are joined at one end forming the measuring hot junction. And for the working principles, I will let my partners to explain it.
As per as my one of the colleagues said that we choose thermocouple type K. So there's a Seebeck effect in thermocouple type K. So what is the Seebeck effect? Okay, we can see that voltage or electromotive force or EMF, you can say that like that, is generated when there's a temperature difference between two dissimilar metals. So, what is the dissimilar metals? We can say that when the hot junction is exposed to a temperature, a voltage produced that is proportional to the temperature difference between the hot and cold junctions. So, as we can see the picture, there is a hot and then cold, and then between the hot from hot to cold junction, there's a temperature difference. So that this we call Seebeck effect. Another thing in thermocouple type K is voltage generation is one of the most important thing in thermocouple type K. The voltage generated by the thermocouple is a result of the different electron densities in the two metals, which is chromal and then aluminum. As temperature increases, the electron in the metals gain energy and move, creating a measurable voltage difference. A hot junction is in the end of two metal wires that that is exposed to the measure temperature, and also other wire ends are preserved at a fixed reference temperature at the cold junction, which is called a reference junction. So this is for voltage generation. And another thing I want to share with you all guys is measurement is a important thing in thermocouple type K, because the voltage in thermocouple is very very small, typically in the microvolt to millivolt range. So the voltage is measured by a thermocouple thermometer or data acquisition system, which uses it to calculate the temperature at the hot junction. So this is for the measurement for thermocouple.
Next, we're going to talk about the advantages of type K thermocouple. First of all, it has high sensitivity. It generates around 41 microvolt per degree Celsius, which indicate high in sensitivity to temperature changes. The second one, it has high temperature sustainability, which offers high stability at high temperature, which is suitable for application in high temperature environment. The third one is cost effective compared to the four other sensors. The fourth one, it has wide temperature ranges. They can monitor a broad range of from extremely low to high temperature, which also enhance their versatile in various application. The fifth one is durability. They resist to oxidation and also corrosion, which makes them durable and also suitable in hostile or challenging environment. The sixth one, it has fast response time. It responds quickly to changes in temperature and also provides real-time temperature reading with fast response time. The last one is versatility. They can be used across a wide range of commercial and also scientific and also in industrial application due to the robust and also adaptivity. What are the disadvantages of thermocouple? The first one is accuracy. The thermocouple generally has lower accuracy compared to RTD. The second one is temperature gradient. Temperature varies along thermocouple wires and at the reference junction can affect the accuracy. The third one is signal stability. Output voltage is typically low and require precise amplification and also processing. The last one is cold junction compensation. It is essential for accurate reading and compensating for reference junction temperature. So the next slide is about application. There are a few application in various area. The first one is industrial process. It's been used in furnace, kilns, gas turbine exhaust, high temperature industrial process. The second application is HVAC system, which also known as heating, ventilation, also air conditioning. It's been used for temperature monitoring and also control in buildings. Third one is automobile industry. It's been used to monitor the engine temperature and also monitor the exhaust system. The fourth one is scientific research. It's been used to measure in research laboratories and also facilities. The last one is food industrial. It's been used in food storing, food processing, and also food cooking processes. So how do we calibrate and also maintain the system of thermocouple? For the calibration, we regularly compares the thermocouple reading with the known reference and also adjustment of reading to ensure the accuracy. For the maintenance, we check the corrosion, the wear and physical deterioration, and also ensure the insulation and also connection integrity to prevent errors from interference and also contacting the resistance. Next slide is about consideration of thermocouple placement, also insulation, and also connection. For the placement, ensure the hot junction is correctly positioned for the reliable temperature reading, and also maintain good thermal contact with the environment. For the insulation, we must properly insulate the thermocouple wires to prevent electric interference and also ensure accurate voltage measurement. For the connection and the material, you must use appropriate connection and also material compatibility with the type of thermocouple and also prevent the introduction of error through the proper selection and also uses of the material.
Hello, now we are going to talk about the working principle of system of the thermocouple type K sensors. A thermocouple is made up of two dissimilar metal wires which is connected at one end and known as the hot junction. The remaining end, known as the cold junction, is connected to a measuring instrument. Temperature gradient. The temperature inside the boiler, hot junction, will form temperature gradient with a known reference temperature, which is called the ambient or cold junction. The Seebeck effect that causes an electrical voltage to be created when there is a temperature difference between the hot and cold junction. This produces voltage. The output voltage is directly proportional to the temperature difference. Signal conditioning, which the output voltage is sent to a signal conditioning unit in which it is amplified, filtered, and converted to a digital signal. Next is the temperature calculation. In this step, microcontroller or temperature monitoring system interprets the digital signal and utilizes pre-calibrated data to convert the voltage into temperature reading. Monitoring and control. A control panel displays readouts of the temperature data, or it is sent to a supervisory control and data acquisition such as SCADA SCADA system for real-time monitoring. In the case where the temperature goes above the predetermined maximum, the system can sound off alarm or even take place to safeguard the heat from extra leaning to paint.
Hello guys, now I'll be looking at how the thermocouple type K works in real life. We have designed a Tinkercad simulation for this. First, when the thermocouple type K is exposed to a temperature, it will give out a feedback to the Arduino board. And this Arduino board will give a feedback to our LED lights. So when the temperature is increased, a green color light will light up, followed by blue, and then finally is yellow. In real life, these lights represent the digital output reading of the thermocouple type K. This is the Arduino coding used to set up our Arduino. So we have set our baseline Celsius and Fahrenheit as an integer, and we have used if constants to set up our coding. Thank you for listening until the end. Farewell and thank you.